All right. Welcome everybody. Today we're going to talk about section 6.5 trapezoids and kites. And obviously I'm not here, so I'll try to make sure that I don't drone on too long here. And you guys should be able to get through this and have some time to work on your homework. So, first of all, we're going to talk about trapezoids first, okay? So your book defines trapezoid as a quadrilateral with exactly one pair of parallel sides. So if you look off to the right-hand side here, I have a trapezoid A, B, C, D, okay? The top and bottom of this trapezoid are going to be my parallel sides because they have these little arrows indicating that those are going to be parallel lines, okay? Those parallel sides, as you can see in the picture here, that's what we call bases. So we talk about base 1 and base 2. Obviously, they're two sides, so that's why we call them base 1 and base 2. Okay? Then, because we have bases, we have something called base angles. Okay? Just like in a triangle, we had base angles. We have these in trapezoids as well, and it's going to be the angles that touch a base. So, for instance, angle D and angle C are going to be base angles. Okay, they are formed with a base, but going off of that being our base angles, that means angle A and angle B are also base angles because I have a base up top. Then the other sides that are not our bases. So I've talked about bases. I've talked about base angles. Okay, we call those legs. You guys can see those here. Okay, I remember their legs because I think of them as keeping the trapezoid up. Okay, that's what extends it up and down, just like your legs hold you up. So they hold up that top base if you want to think about it like that. That's how I remember that they're legs. There's a very special case where legs can actually be congruent to each other. So if you look at this picture to the right that's not as colorful here, if I have these two tick marks here indicating that these are the same length or congruent, we call that an isosceles trapezoid. Just like we talked about isosceles triangles having two sides that are congruent, if you have your two legs congruent, you have an isosceles trapezoid. We got a couple theorems that go along with trapezoids. If a trapezoid is isosceles, then each pair of base angles are congruent. So angle A is congruent to angle B. Angle D is congruent to angle C. Okay? Big thing here, trapezoid has to be isosceles. If it's not, then it's a little different there. Then, if theorem 6.15, if a trapezoid has a pair of congruent base angles, then it has to be an isosceles trapezoid. So, since I'm given off to the right here that angle D and angle C are congruent to each other, then that is enough for me to say that ABCD is an isosceles trapezoid. I can say that AD is congruent to BC. Again, it's got to be the same base angles. So angle B and angle C are from the bottom base. I would call that base 2. Since they touch segment DC, they're touching the same base, so they're congruent. And the last one we want to talk about, a trapezoid is isosceles if and only if its diagonals are congruent. So if AC is congruent to BD, then I know that AD is congruent to BC. So those two legs have to be congruent to each other. Or I could start you the other way. That's the nice part about that if and only if. I could tell you that AD and BC are congruent, or I could tell you that it's an isosceles trapezoid, then you would know that these diagonals, AC and BD, are going to be congruent to each other. So take a look at an example here on the right-hand side of your page. PQRS is an isosceles trapezoid. Okay, this part is important. It is an isosceles trapezoid. We need to find the measure of angle P, angle Q, and the measure of angle R. I'm going to start right away with the measure of angle R. Okay, I've got my two parallel sides right here, SR and PQ, and I know that S is 50. Since this is an isosceles triangle, angle R also has to be 50. And now I need to find angle P and angle Q. The nice part is, since this is an isosceles, measure of angle P and the measure of angle Q are going to be equal. Now, you can do this a couple different ways. The easiest way is, since we're working with two parallel lines, SR and PQ, and I'm just going to look at angle Q. That'll be the easiest. Okay. Angle Q and angle R are consecutive interior angles. If you go back to chapter 4 or 5, I think it was chapter 5, we're dealing with consecutive interior angles being those parallel lines, and that means they have to add up to 180. So I can go the measure of angle Q plus 50, our measure of angle R, that has to equal 180. Okay, they have to be supplementary. Subtract your 50, and you get that the measure of angle Q is equal to 130. So we're at 130, meaning that measure of angle P has to also be 130. Another way you can do that, just using a theorem that we talked about in this chapter, all of these angles have to add up to 360. So S and R take up 100 of that 360, which leaves me 260 to be made up with by angles P and Q, and they have to be the same, so I cut that 260 in half and get 130 each. That's another way that you could do that. So, got a couple different options there. Whatever you want to use is fine with me. Then, we also have a mid-segment of trapezoids. So, we did actually talk about a mid-segment theorem for triangles, and this is going to work very, very similar to mid-segments of triangles. So, first of all, a mid-segment is going to connect midpoints, which are halfway in between, or it's in the middle of a segment. So, if I look at AB in the trapezoid that I give you here, okay, this line right here, okay, that point that I just put on there is halfway in between A and B. So, these two little pieces are going to be congruent, and same thing on the right side. That's why they have two of those little tick marks. So that's what a mid-segment is. It connects the midpoints. Midpoints are going to be halfway on a segment. So mid-segment theorem for trapezoids now, okay? Your mid-segment is going to be parallel to both of these bases. So AD and BC are parallel to each other. MN is actually parallel to them as well. And it is going to be the average of those two bases. So add those two bases together and divide it by 2. So you think about finding midpoint of numbers. Okay, you're just finding your average there. Add them together, divide by 2. Same thing here with your mid segment. So, little example of this, a baker's making a cake like the one shown here at the right. The top layer has a diameter of 8 inches, and the bottom layer has a diameter of 20. So, I've got 3 tiers to this cake. Top one is 8 inches, bottom one is 20 inches, and we want to know how big should that middle layer be. Okay, so we're looking for what's going to be halfway in between. So I know that my mid segment, DG, has to be 1/2 of EF plus CH. Okay, that's just that mid segment theorem that we just talked about on my last slide, and it is right above this problem on your note sheet. Okay, I'm looking for DG, but I know that EF is 8, and I know that CH is 20. So DG is going to be 1/2 of 28. 1/2 of 28 is going to give me 14. So middle layer should be 14 inches. Then, now I want to switch gears a little bit. We're going to talk about kites. Okay, if you look, actually, I'm going to define kite for you first. A kite is just a quadrilateral that has 2 pairs of consecutive congruent sides, but opposite sides are not congruent. So what that means is, off to the right here, I've got a picture of a kite. It's right below it on your note sheet. Okay, what that means is you can see up top here, okay, the 2 sides that are right next to each other are congruent. So I have 1 tick mark and 1 tick mark. I have 2 tick marks and 2 tick marks. Okay, the ones with 1 are congruent to each other. The ones with 2. Okay, so I have consecutive, one right after the other, congruent sides. So they're right next to each other and they're congruent. But if I go across this quadrilateral, this shape, okay, those 2 sides are not going to be congruent to each other. So you go across from 1 tick mark, okay, you go across the quadrilateral, you got 2, or you can work the other way. But those can't be quadrilateral, or those can't be congruent. For it to be a kite, that would be something else. Okay, and this one, most people like kites because if you look at this, especially the picture that I just drew on there, okay, it looks just like a kite that you go fly. So that's, a lot of people will remember this name pretty easily because it does look like a kite that you would go fly in the wind there. Couple theorems about kites here. If a quadrilateral is a kite, then the diagonals are going to be perpendicular. So if you look here, I've got diagonal BD and I have diagonal AC. Okay, these have to be perpendicular to each other. It'll happen every time just by the way that we define our kites and the way kites are set up. Always perpendicular, always form that right angle or 90 degrees. Then, if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. Okay? And it is going to be the angles that are made by 2 non-congruent sides. So, angle A and angle C are going to be congruent. Okay? Angle B and angle D are not congruent. Okay? They cannot be. Again, it's just how we set up kites. So it's always the 2 angles that are made up by 2 non-congruent sides, angles A and angle C. So I give you here WXYZ is a kite, so the diagonals are perpendicular. you can use the Pythagorean theorem to find side lengths. And instead of having you guys work through this, hopefully you guys know Pythagorean theorem. Remember, if you don't, it is up on my wall. It's like the big poster on my wall that says Pythagorean theorem in big letters. But that's going to be a squared plus b squared is equal to c squared, where, remember, c is going to be the side across the triangle from that right angle. So I can find wx. So I have a side length of 20 and a side length of 12. So I take 20 squared plus 12 squared, and that's going to give me 544. And you can type that into your calculator. Square root of 544 is roughly 23.32. Okay, since I'm dealing with c squared, I just want what c is by itself. That's why I have to take the square root of that. XY. Okay, this one actually ends up with 12 squared and 12 squared. So 12 squared plus 12 squared gives me square root of 144 plus 144. So square root of 288. And if you type square root of 288 in your calculator, it'll spit out that is roughly 16.97. So because it's a kite, you can always use that Pythagorean theorem to find those side lengths. And the last example I want to take a look at here before you guys move on to your guided practice, we want to find the measure of angle G and the measure of angle J in the diagram to the right. Now, I look and I know that H is 132 degrees and angle K has a measure of 60 degrees. Hopefully by now you guys know that 132 and 60 are not the same number. If you don't, I got some bad news for you. But that means, going back to our theorem about kites, there has to be exactly one set of congruent angles. That means G and J have to be those congruent angles. Okay, so right away, I know that the measure of angle G is equal to the measure of angle J. So what that allows me to do is, I'm still working with a quadrilateral, okay? And you guys know that all of the angles in a quadrilateral have to add up to 360 degrees. Since the measure of angle G and the measure of angle J are equal to each other, I can actually set up an equation where I substitute one in for the other. So the angles I'm going to work with, I'm going to put everything in terms of the measure of angle G. So I'm going to go the measure of angle G plus another measure of angle G, okay, substituting that in for J, plus 132 plus 60 has to equal 360. Okay, so I have measure of angle G plus measure of angle G. That gives me 2 times the measure of angle G. And honestly, if you want to put 2G there, that's fine. I don't really care. 132 and 60 gives me 192. And that has to equal 360. And now we just go through solving our equation. I'm going to subtract my 192. So I have 2 times the measure of angle G equals 168. Since I'm multiplying measure of angle G by 2, I'm going to divide both sides by 2. I'm going to get that the measure of angle G is equal to 84. Since the measure of angle G is 84 degrees, measure of angle J also has to be 84 degrees because they are our one set of congruent angles. So those are going to be equal. Okay, Take a peek at your guided practice. Obviously, I'm not going to sit here and wait for 5 minutes and have 5 minutes of dead air while you guys work on this. So my recommendation, pause the video, work these out. Okay, all you got to do is decide whether the quadrilateral is a trapezoid, an isosceles trapezoid, a kite, or none of these. That's also a possibility. So pause your video, try these, and then I'll come back and go through these with you guys like I would in class. Okay, hopefully you guys have already paused the video, come up with your answers. So this first one, number 3 here, okay, I've got two parallel lines. These are parallel, and so right away, I know I'm working with either a trapezoid or an isosceles trapezoid. Okay, just how we define a trapezoid as a quadrilateral with one pair of parallel sides. So since I have these little tick marks here, that means that these two sides are the same length, meaning this is an isosceles trapezoid. I move on, I take a look at number 4. Okay? I have no parallel sides, at least nothing marked, but I do see that I have tick marks here with one tick mark, and I have 2 tick marks here with 2 tick marks. So no parallel sides, that rules out trapezoid and isosceles trapezoid. So my options are either kite or none of these. Since these congruent sides happen to be next to each other, and when I go across, I see a different set of tick marks than what I started with, this is going to be a kite. Plus, it helps that it looks like a kite. Looking at number 5. Okay, I've got parallel sides here. Okay, I have parallel sides. I have exactly one pair of parallel sides. Therefore, I'm working with a trapezoid. All I have to do now is decide whether it is isosceles or not. I look at the 2 sides that are not parallel to each other here. I see that I do not have markings to indicate that those are congruent. And in this case, you can kind of eyeball it. You can see that these are probably not the same length. So this is just a regular trapezoid. Okay, so you guys already have your assignment. That's in your packet. We'll check this when I get back. If you guys have questions, feel free to shoot me an email, whatever. I will do my best to help you. I'll try really hard to keep up on my email, even though, you know, I am gone for a reason. So I may not be back to you right away, but I will try my best to answer as quickly as I can. So that's what I got for you guys. Go ahead, try the homework. We'll check that when I get back.